So, hello and good evening, or good morning, or good afternoon, depending on which time zone and which country you're in. So, welcome to today's online seminar from CIHT Dubai, which is on the topic of connected and autonomous vehicles, planning the future of road transportation. Just a couple of housekeeping notes, please. Unless you're speaking, can you keep your microphone and your camera turned off at all times? It's likely that you will want to ask questions or raise points. If you want to do that, can you use the chat feature of Zoom? And that channel is being moderated by Nabras, who will bring those points up in the Q&A session at the end of the seminar. When asking questions, if you can confine your points or questions to the topic under discussion, connected autonomous vehicles or the highways and transportation sector generally, please. And then finally, the seminar is being recorded and there will be copies available by emailing us at ciht.dubaigroup@gmail.com. So the agenda for today's seminar, we have four expert speakers on the topic. I'm doing a brief introduction. My name is Jonathan Spear. I'm the chair of CIHT Dubai, and then we'll be followed by four presentations and then a Q&A session in about an hour's time, which will be moderated by Nabras before we hope to finish at about 7:30 local time. We may go on a few more minutes depending on the discussion. We'll see how things go in that respect. So welcome to tonight's seminar. As I say, my name is Jonathan Spear. I'm the chair of CIHT Dubai, and I'm a transport policy and strategy advisor based here in Dubai. Just a few words about CIHT, which stands, most of you may be aware of this, the Chartered Institution of Highways and Transportation, and it's a UK-based professional association, a membership organisation based mainly in the UK, but actually out of the 14,000 members of the institution, over 1,000 are based overseas, including here in the UAE and the GCC. And the institution is here to promote professional learning, debate, skills development and networking across the transport planning, highways profession. And also being a member of CIHT is an indication that you wish to develop your career within the transport planning and the engineering sector, and have various supports and tools to allow you to do that. Principally, that's around supporting access to qualifications, whether that's engineering, or whether it's actually the transport planning qualifications of various types, including the Chartered Transport Planning Professional. And we also support road safety skills and accreditation through the Society of Road Safety Auditors, or SORSA. As I say, CIHT is based in the UK, but there are a number of overseas branches, and there is now one in the United Emirates. The idea behind CIHT Dubai was actually conceived at the World Road Congress, which was held in Abu Dhabi at the end of 2019. And it's really here to act as a forum for debate, discussion around highways and transportation professionals in Dubai and the United Arab Emirates, to promote professional standards which may support the local transport sector, and also to support individuals in their career development and aspirations. Our initial focus is on seminars and knowledge sharing, such as tonight's event. And of course, we couldn't have picked a worse time to launch CIHT Dubai, because it was immediately prior to the COVID-19 pandemic. Having said that, we haven't let COVID get in the way. We actually have developed over the last year in quite a number of ways. We have a committee, so these are the current members of the committee, and we're always looking for new members to help develop the branch. So if you're interested, please get in touch. Our main activities at the moment are organising a series of seminars, initially face-to-face and physically in Dubai, and now online, which allows us to reach an audience outside of the UAE and Dubai and internationally. And we've had, I think, registrations from everything from the USA, the Eastern USA, in the East, sorry, in the West, to Singapore in the East. So we're covering kind of multiple time zones with a range of different topics, ranging from Hyperloop, road safety audit, the impact of COVID-19 on the transport sector, micromobility, and tonight's seminar on self-driving transport or connected autonomous vehicles. So that's enough about CIHT itself. Now, just to introduce tonight's topic then, which is connected and autonomous vehicles. And I'm not going to say very much because I'm going to leave it to our expert speakers to introduce various aspects of the topic. But clearly it's a hot topic. It's an area for debate within the transport planning and the highways profession. And connected autonomous vehicles are, in fact, not in the future. They are here in various shapes and forms, whether it's autonomous shuttles or pods, whether it's investing in driver assistance or autonomy within the automotive sector and road vehicles, or whether it's on public transport or indeed in warehousing, logistics, or mining. So autonomy has been around for a while. It continues to develop, and it's also here actually in Dubai. And through the RTA and other public agencies, there are various initiatives going on to test, demonstrate, showcase and deploy connected autonomous vehicles in various shapes and forms, whether it's autonomous pods, whether it's looking at automotive technology. And of course, the Dubai Metro is the longest driverless metro in the world. So driverless technology is already deployed on public transport within the Emirate. And as we'll hear shortly, there is a Dubai self-driving transport strategy and roadmap, which aims to go a lot further than that. If we look at how these technologies are developing, we see applications in the automotive sector, in personalized and public transport, importantly in autonomous freight and logistics, including e-deliveries as well, and in driverless mass transit. So a range of applications in different sectors pursuing at various rates moving forward. There's a roadmap moving forward. This is an example which looks at levels of autonomy, connected vehicles, different aspects of assistance for road safety. And there are a range of different factors which will control how long that roadmap takes towards what you might call full automation of the road sector, whether it's technology development itself, whether it's regulatory approval, whether it's public and consumer attitudes, and so on. And there's a wide range of predictions about how long it will take for connected autonomous vehicles to really move into the mainstream. And indeed, whether autonomy will combine with other forms of technology, whether it's electrification or different business models, moving from, say, private ownership to taxis, ride-hailing, public transport. So actually, some people now talk about shared electric, connected and autonomous vehicles, or CCAVs, which is a much bigger proposition, which promises to transform the sector in the years and the decades ahead. Just to finish the introduction, when you registered for this seminar, we posed 3 questions to you, principally in the area of driverless cars. Really to kind of get a feel for what your views were of how some of this technology might develop in the future. So the first question we asked was, how comfortable are you to ride in a driverless car? Actually, most of you seem to be reasonably comfortable, almost 50% very comfortable or comfortable, and over a quarter being a bit more neutral. So if you compare that to being uncomfortable or a bit uncertain, you're relatively optimistic and up for riding in a driverless car. We also asked when you thought driverless cars would become commonplace on public roads. And here you're pushing the envelope out a little bit. Most of you thought that it would be at least 10 years, 44%, and again, another quarter almost thought it would be more than a decade before they become commonplace. So actually, we're not going to see driverless cars on the roads very quickly. It might take actually quite a long time for them to become a mature technology and deployed on the road network. And then finally, we asked you if driverless cars did become proven to be safe and certified, should driving by human beings actually be banned? And here you were very clear, even if cabs really do take off and become a mature technology and deployed, then 2/3 of you thought that actually driving should not be banned. And therefore and some people have almost talked about driving as a human right that should be maintained in the future, irrespective of the technology. So it's not particularly a scientific survey or poll, but it does give you some interesting responses about where, certainly in terms of driverless cars, the technology is going. So just to move on from the introduction then, we have 4 excellent speakers to address you tonight. Dr. Jochen Lohmiller from PTV Group, and also Peter Sukanek, also from the PTV Group, talking about the future of autonomy and how it's applied in future modeling. We're honoured to have Khalid Al-Awadi, who's a director for transport systems from the Roads and Transport Authority, who will be presenting the Dubai self-driving transport strategy and challenge, so what Dubai government is doing in this area. And then finally, Andrew Pearce from Atkins, who will be taking a slightly shorter term approach to what is actually deliverable and practical with connected vehicles in the near term, and what will be the benefits of some of the technology which actually is available now. So different dimensions on the debate, but hopefully it will be very interesting and a valuable debate and Q&A at the end. So just to introduce our first speaker then, Dr. Jochen Lohmiller is a Principal Product Manager of Microsimulation Mobility at the PTV Group based in Germany, and he's responsible for PTV's product portfolio in the context specifically of transport and road simulation. He's actively focused on a range of research projects and development of different methods and approaches. He's worked at PTV since 2014, and before that he studied mechanical engineering at the University of Stuttgart and later earned his doctorate in the area of traffic engineering. So with no further ado, Jochen, the floor is yours to give your presentation.
Thank you very much, Jonathan. Yeah, as said, we from PTV Group, we produce software for building some models to estimate what could happen in the future, how a future could look like. And we're a little bit present on that and how that can be viewed when we think of autonomous vehicles. So how could a future of autonomous vehicles look like? Next slide. So this is one example, and of course, if everything is completely controlled, if we would have 100% of autonomous vehicles, of course, the rules, the traffic rules, they can be very different. We can optimize more things because we have knowledge, we have control of vehicles. The human factor is out of the equation, and could be a lot of potential. But yeah, as you might see, this is one potential future, how it might look like, but it seems a little bit risky and uncomfortable for some of the participants. But with this presentation, I would maybe just look a little bit how such a future with autonomous vehicles could look like. Next slide. So clearly a focus is safety. And here an example from Waymo, which is in some parts considered as the leading company in self-driving transportation. So they clearly state they building a driver which is safe. And actually today, 94% of accidents are caused by human errors. It's not about the technical mistakes. So there is, of course, a huge potential specifically on safety. Next slide. But safety is not all. Next click. Reduce accidents, clearly, but there's also other potentials, like reducing emissions. So they might drive much more efficient autonomous vehicles, or even if they know about the status of the next signals, they can already adapt early to reduce. So there's potential that we live in cleaner cities in the future. Click. So parking requirements, it's very desirable that you get off your vehicle close to where your destination is, but with autonomous vehicle, if the vehicle can drive itself, this is not important. It just, as with a taxi, you drop off where you want to go, and then the vehicle takes care about parking itself. Click. And then this is a focus area, improve congestion and reliable journey times. This is where I want to focus a little bit, how it may affect traffic flow in the future. Next. So enhance mobility for all. Clearly, if you don't need to have a driving license, but the vehicle drives itself, it gives opportunity for kids, for people who are disabled, who are not able to drive. They can also be more mobile. Next. And specifically with the reduction of parking requirements, there's options to free up very valuable space in our cities to relocate them, as for this example, to a restaurant or something. And next slide. Yeah, it frees up commuter time. So we can have time in the vehicle to interact with people, to talk, to work, and it will be considered differently compared if you need to drive or if you just sit in the vehicle and commute and even sleep. So the key questions are, first is the potential for increased kilometer traveled. Click. It may be, what is the difference? Will there be more kilometers traveled, less kilometers traveled? Next is how will the different AV, autonomous vehicle rates of the penetration rate, how that will work. Next slide, how will they really be programmed to drive? It's uncertain yet. Next one is how our infrastructure would need to look like. It looks like that the existing trials, they are be able to work on existing infrastructure. Next one, and this is now from a city's perspective, who will provide the regulation for them to drive if needed. Next one is, it was also mentioned, like if we have the opportunity to autonomously operate a taxi operation, and there are a lot of players who are trying to get into the market, how will that interplay these different providers with each other? And next one is then the curbside pickup and drop off, how they operate, because we will see much more this valet park-like parking if our vehicles can in the end do the last mile to the parking spot themselves. So now I'll present you a little bit of a Lisbon study, and this is how a future could look like. What is that? It's from the OECD. It's a study made, okay, what might happen if we have 100% self-driving vehicle fleets? So there's no private cars. Of course, it's an extreme scenario. There is car sharing, so no privately owned vehicles anymore. I know 60%, I just learned 60% of you don't like that future, me either, but just a scenario. And all the trips which are today observed in Lisbon, they are replicated, so the private cars and the bus trips by this vehicle fleet. They did not, there was a use case also, but the mass transit, the trains, they kept because it's just impossible to do that trips with an autonomous vehicles fleet as well, the massive traffic transport system. So if you go to the next slide, you see the number of the vehicle numbers which are needed to serve all the needs, the trips of today's Lisbon city with autonomous vehicle fleet. So you would only need 17%. As said before, high capacity public transport still remains in existence, but it's car sharing. So it's not even ride sharing, meaning not multiple persons sit in the same car, it's one after another. So the vehicle fleet is serving all trips individually. So instead of a vehicle being used 15 minutes a day and only 30 kilometers traveled, of course, in that scenario, vehicles are used 12 hours a day and travel nearly 200 kilometers. So it's a massive increase in usage of individual vehicles, but bad news for OEMs who produce cars, we only need 17%, of course, because they operate much longer. There might be earlier you will need vehicles. On the next slide, it gives an indication of the off-stream parking. And in such a scenario, you would only need 10% of today's existing parking lots. And that is, of course, a huge potential for a city in such a scenario. And I already sneaked a little bit in the slide of the next presenter then, Khaled, who are also showing some numbers, not that extreme, but also Dubai have made some thoughts about the savings in parking requirements. But it's not all good news. On the next slide, these vehicles will travel 44% more kilometers, miles than before. The reason is this, as individual, there are these car sharing vehicles. And of course, once a trip is completed, the vehicle needs to go to another pickup location for next trip. And there are these empty routes, or empty, would say, there's no trips where no passenger is in the car. These are the additional trips, the additional kilometers driven. So that is, of course, an extreme scenario. But how will the future look like? On the next slide, I show you a print of year 1515. That's from a famous German drawer, painter, Albrecht Dürer, and he drew a rhinoceros. But the interesting part, and this is the analogy to today's self-driving transport, is that Albrecht Dürer, who drew the picture, never have seen himself a rhinoceros. He just heard from people saying something, got a little bit of information. And this is where our situation today, we hear a little bit, we see some vehicles operate, we see some estimate, we see some consultants giving models, estimation when that will take place, etc. And we try to paint a picture. And this is what we do also with transportation models. We use transportation models to include some assumptions, how it might be, how it could look like, and then we draw such a picture on how self-driving could look in the future, as I was showing in the Lisbon study. And this is how Dürer painted that picture, and you see some analogies. Okay, there at that time, 1500, there were some knights, and they were reporting of a thick skin, and he was just using like this armor, what he was used to know, so drawing the picture. And it's not too bad. So hopefully also with our models, we're not too bad in estimating the future. On the next slide, the question is how this transformation will look like if we introduce autonomous vehicles. So on the x-axis on the right, if we get more and more AV vehicles, autonomous vehicles, and penetration rate, how will that change in terms of throughput? And there are assumptions that it's getting worse, because we see the first trial vehicles operating on the streets. They drive very, very careful, much careful as a human driver. And that will, of course, have negative effects on the throughput. But let's look in some studies. One prominent study on the next slide is a study from the UK government, and it was executed by Atkins. So Andrew from Atkins will tell a little bit more, not on that study, but we have them. And they have used our modeling software to estimate how it could look like. And it's, of course, all based on assumptions. So they have made some assumptions on what is the headway, so the distance between two vehicles, how they follow each other. And that, of course, that distance will result in completely different throughput. The closer they drive, the more throughput you have. And they made some assumptions also on the cautiousness for different levels. And then on the right-hand side, you see, now in that case, they also have looked at a motorway example, but this is an urban scenario, that the average junction delay will decrease with higher penetration rate of autonomous vehicles. So for the junction 3 on the right-hand side, the fully signalized, there the potential is only there with minor potential, only with 70%. So we need already 70% on autonomous vehicles that we see then a benefit. That is, of course, late. Next slide is an example we did ourselves. So just also same approach. Okay, we define how vehicles follow each other. As of today, typically, at least in Germany, I know in Dubai they drive a little bit more aggressive sometimes, but their conventional vehicles, so a human driver follows a human driver with 0.9 seconds, same as a conventional vehicle will follow a CAV, a connected autonomous vehicle. So a human driver doesn't make any difference if the leading vehicle is a human or if it's a automated vehicles. But then how will the automated vehicles drive if they follow to a conventional vehicle, a human driver? And there are three scenarios, 1.5, 2.0, and 2.0 and 2.5 seconds, leading to higher, meaning more safety. That might be a pessimistic approach, but we just wanted to show how the effects could look like. And of course, first, they need to stick to the rule. They cannot drive as humans in the rush hour, following each other, and they want to be safe if they need to follow conventional vehicles. But then, of course, we have the benefit if a connected and autonomous vehicle follows another connected autonomous vehicle, so they get a connection to each other, and then they have the potential of driving with much lower headways, even than conventional vehicles today. So they can kind of form some platoons. And then there is, of course, then the opportunity. If you go to the next slide, you see the results. So, of course, because of connected autonomous vehicles will drive with higher headway, first, the throughput decreases. And it requires, even in the optimistic scenario with 1.5 seconds, it requires at least 30% of vehicles. Then we get a benefit. The benefit comes from if connected autonomous vehicles follows another connected autonomous vehicles, but therefore the probability with lower rates is lower, and the probability that a connected autonomous vehicles follow another connected autonomous vehicle is higher. So, and in the end, of course, with 100%, all of them will drive with 0.6 seconds, and that will lead to a capacity of around 3,300 in our example. Next slide. And this is probably a rather new and a very popular study, also being used based on our modeling tools. So for the highway capacity manual, so the guideline for the US on how to build roads, they came up with some capacity adjustment factors for connected and automated vehicles. So they did simulations, and from that simulation, they derived these capacity adjustment factor on the table you see on the right. So if you read that with a higher market penetration rate on the y-axis, then there is an increase of capacity because the number is always larger, equal and larger to 1. With connected autonomous, we have higher capacity, and extreme to in these different starting capacity depends on how optimistic or the situation is. But in the end, with 100, I mean, if you do the math, you always end up at 3,200 vehicles per hour per lane, which we might have in the future. So meaning we can really have much more throughput on our roads if we have higher rates of automated vehicles. So here the US is clearly drawing a positive picture, not saying it's going any worse. We're still not 100% sure if that is the future, or if even, and then there comes regulation into place, like if a city or if an operator, highway freeway operator says, I don't allow you to operate because you destroy my capacity on the road. And that could be a regulation. Only if you can drive at least as good as a human driver, then you're allowed to drive on the road. And that might be optimistic because we have issues in our cities with congestion anyway. So that could be a good approach. So far as an overview, and I said before, my colleague Peter Sukenik, he will later explain a little bit more in detail about the modeling, what is behind. Yeah, and thank you very much. With the next slide, I end, and looking forward also to hear the other presentations. Thank you.
Okay, thank you very much, Jochen, for that introduction. And as you said, I think Peter is going to talk about those modelling issues in a bit more detail shortly. But before that, we have Khaled Al-Hawadi, who is, as I've said, Director of Transport Systems at the Dubai Roads and Transport Authority, the RTA. Khaled has more than 17 years experience in management system excellence and recognized experience and strengths in managerial skills and technical capabilities in technology, smart mobility, operations and strategy. He's been involved in the fields of robotics and also unmanned aerial vehicles. So these are autonomous vehicles up in the air rather on the roads. And he's currently leading the team supervising the implementation of Dubai's autonomous transportation strategy, self-driving strategy, which aims to transform 25% of all trips in Dubai to the autonomous mode by 2030. And with that, Khaled, the floor is yours to give your presentation. Thank you.
Thank you, Jonathan, for the introduction, and thank you, Johan, for the very interesting presentation. Quite interesting forecasts and facts, actually. So, yeah, so what basically I will be perhaps try to brief you in this short session, what Dubai, in fact, is doing in terms of the strategy, and also where we are standing today and why we are doing this. And perhaps I will be starting with why we are doing this. So what is the drive on the city of basically looking after the autonomy and self-driving and the connectivity when it comes to the transportation system? So if you don't mind, can I have the next slide, please? So this is the agenda that I'll be taking it through. So next, please. So yeah, in 2014, His Highness, the Prime Minister of UAE and the ruler of Dubai, Rashid, he announced that he's looking to make Dubai the smartest city in the world. And this is, let's say, a goal, and this is a strategy that has been defined to be achieved in 2021. Definitely, there are different strategies that are contributing to make this achievement when it comes to the basically digitization, smartness, and definitely the mobility is one of the main pillar to this strategy. Next, please. Also, when it comes to basically to the important definity of the transportation system, like in any, let's say, city in the world, it's a backbone for the economics of the city. And this is also definitely very clear in Dubai 2040 Urban Master Plan, which even was just recently was launched and was basically updated and launched. And the aim is to make Dubai the smartest, the aim is to make Dubai the best city for living in the world by 2040. Definitely looking into different aspects when it comes, for example, making Dubai the best city. But as we can see over here, where I also make an highlight, the aim is basically to make the transportation system more friendly, more reachable to the population. And one of the goals is basically 55% of the population in Dubai by 2040 will live within 800 meters only of main public transport stations. So in this case, you need really to have a very resilient transportation infrastructure that will be reachable, that definitely promotes the different aspects of this transportation, like what Johan was covering in his presentation. Shared mobility is one of the main also aspects to this. Next, please. Also, it's worth mentioning that the vision of the Road and Transport Authority of Dubai, which is actually driving this strategy on the government level, is to make Dubai a world leader in seamless and sustainable mobility. And definitely, this is translated into a number of, let's say, strategic goals that we are driving on the city, like making Dubai smart, also having integrated mobility, let's say, on the city of Dubai, which is translated into integrated Dubai, or basically it's a goal that RTAs they are driving on the city. Sorry for that, I'm just losing my voice. If I can have this next slide, please. So talking about the strategy itself, so the main aim of the strategy and the main goal of the strategy, which was launched in April 2016 by His Highness Sheikh Mohammed bin Rashid, the ruler of Dubai and the Prime Minister of UAE, is to make 25% of the trips in Dubai by 2030 to be done by self-driving transportation mode. So this is a strategy and this is a goal, and perhaps Dubai was one of the first, or even was the first city in the world to set a clear objective what needs to basically to be achieved by a certain year, which is 2030. And from that aspect, definitely the government, which is led by His Highness Sheikh Mohammed, and also is basically the driver, which is the Road and Transport Authority in the city of Dubai, defined a clear strategy on how to make this achievement, which is translated into a number of pillars and building blocks that the city need to work to make this achievement happen. Next, please. So, the strategy, as I was mentioning, there is a set goal by 2030, and also it is basically a strategy that focuses on multi and different transportation system. So we're not only talking about a robo-taxi, or we're not talking about only self-driving shuttles. It's a multimodal strategy that goes hand in hand with the strategic planning that RTA is doing for the transportation in the city of Libya. And it is actually going hand in hand with the growth of the transportation network in the city of Dubai. So the strategy is focused on different modes. So metro is being one of the modes, and it is directly also contributing to this objective, as was mentioned by Jonathan in the introduction, that Dubai Metro is considered one of the largest, let's say, network for a self-driving electric metro in the world. But definitely there are different elements that would be going into the strategy to contribute into this achievement. So self-driving taxis, shuttles, buses, and also including the marine transportation system will be contributing to this strategy. Now, definitely there are, for this to achieve, there are different, let's say, building blocks that need to support. So if I can see the next slide, please. So these are actually the defined building blocks that was introduced and was captured part of the strategy. So to achieve this, let's say, goal, and to achieve basically the aim of and the goal of the 25%, definitely we need to focus on multi and different building blocks that will be delivering let's say the projects, the different projects that will be supporting achieving the 2030 vision. So legislation is one of the main things that we are working on. In 2019, we have actually made a publication of the official legislation and framework for testing autonomous vehicle in the street of Dubai. And as well as at this stage, we are finalizing the operation legislation that will be allowing vehicles to operate, and we are expecting that will be ready within 1 to 2 years maximum, and will be also there for the let's say OEMs to make an operation in the city of Dubai. And definitely there are the different building blocks that will be we're going to focus in part of this strategy. So the behaviors and acceptance and awareness of the people, and making sure that there is an adaptation for this let's say new modes, as well as definitely we're going to work on the licensing framework, insurance, the infrastructure requirement. Definitely one of the main things that will be enabling the operation of such, let's say, the transport ecosystem in the city of Dubai. Definitely the cyber security and data privacy is always a dilemma where need to be addressed, and also the connectivity when it comes to basically the different vehicles to vehicles and vehicles to infrastructure, or just simply we can say B2X connectivity. High definition mapping is one of also the enablers that we can see that also need to exist in the city to make such operation. Now, all these building blocks definitely are translated into projects that will be executed and already started being executed since the launch of the strategy in 2016. We have, when we started basically the strategy, we captured over 132 different projects that will be executed over 14 years. And this is where actually gonna take us into achieve the objective that we are aiming to have. Next, please. So this is basically just very let's say abstract. Definitely, in reality, is much more complex. But this is what we are trying to basically illustrate over here. That based on let's say the maturity of the technology, where actually we are always assessing on yearly basis, because this is a living strategy that we are always assessing and make sure that we are on top of the evolution that are happening in the technologies, the evolution that are happening in the infrastructure and the different aspects. We have defined, let's say, the different modes and the plans for them and the penetration for them into, let's say, into this strategy and the contribution for them to achieve the goal. So, and definitely for this to happen, we are also trying to make, let's say, a kind of accelerating and also making and creating a courage for let's say OEMs, developers, startup to come here and test and also to make sure that they are accelerating the readiness of their products for this particular market. Next slide, please. So for this, we have launched the Dubai World Congress and Challenge for self-driving transport. And as I was mentioning, that this is a platform that we are using to attract the developers, to attract the OEMs, to attract basically even the academics to provide solutions for different, let's say, scenarios when it comes. I talk about shuttle as maybe we can and as we have seen actually in the previous slide, is one of the first mode that actually is contributing to the transportation system, as well as to the self-driving transportation system, and is aiming to address the first and last mile. So the first challenge was in 2019, and which was integrated and integrated the winners actually in October 2019. The team was first and last mile, where actually we had 5 leaders or 5, let's say, pioneers company that they did actually try to sort of certain scenarios when it comes to the first and last mile. So so this platform, or this say challenge, we are using it to sort out and to accelerate, as I said, the different aspects of this strategy. So the next actually coming cycle of this challenge is happening October this year, October 2022, which is 2022, which is aiming into basically a competition for self-driving logistic mobility pods, or if we can say things like the Amazon or FedEx and similar things that will be used to provide the logistic. Because also the aim of actually having such mode is to eliminate the people, let's say, driving and making trips to deliver these, let's say, smaller parcels or deliveries of the food or similar items. So this is the next challenge that it is taking place in October 2022. Next slide, please. So maybe this is the conclusion of my slide, but why we are doing this? Always, basically, this is the main question. Okay, why Dubai gonna invest millions and billions of dollars to basically to advance the transportation systems, and what will be really the payback and what is basically the benefits for this? So these are the captured strategic let's say, benefits that we are doing. As we know that more than 90% of the accidents are due to human error, and this is something known. So what we are trying actually to increase the safety by 12%. We are aiming to reduce the parking space, and this was touched already in Johan's presentation, that there will be a dramatic, let's say, infrastructure saving, especially the parking. So what we are aiming is actually to reduce the expenditure on let's say, the infrastructure that are required for the vehicles to park, to concentrate more on the shared mobility, more on basically the usability of the vehicles, which also will be leading to increasing the efficiency of the public transportation by a certain percentage, 20%, by making a better usage of the, let's say, transport system, by also making the complete ecosystem connected, reducing the headways between the systems, increasing the density of basically the transportation network and moving people. And this, we expect that going to result also in reducing the cost, because increasing the efficiency will be also can allow the city in offering a better mobility cost to the customer, and as well as definitely the reduction of the pollution, because those systems they will be more friendly. We're going to use less vehicles. Johan gave a very interesting number, which I was not expecting. Actually, 17% only of the vehicles will be required. So definitely with this, we're gonna have a big saving in terms of the infrastructure needed, in terms of pollution that are generated, and definitely this goes hand in hand and better efficiencies and cost, let's say, reduction on the customer side. So these are all benefits that definitely we are looking to be achieved by doing and implementing the strategy of Dubai for self-driving transportation system, which again is aims on 25% of total trips in Dubai on daily basis to be done using self-driving transportation system. Thank you for listening, and this is the end of my presentation.
Okay, Khaled, thank you very much for that overview of the Dubai self-driving transport strategy and the challenge. And I think we're all looking forward to the winners and the results of the next round of the challenge shortly, and seeing what else is deployed on the streets of Dubai in coming months and years. So our next speaker then is Peter Tsukenik, who's Technical Product Manager again at the PTV Group. So we're coming back to a modeling and an appraisal theme here. Peter is a traffic modeler and a consultant with experience in Slovakia, the Czech Republic, and now working for PTV in Germany. He's participated in national research projects related to traffic modeling and collaborated on several engineering tasks in the field of infrastructure assessment, capacity analysis, and the optimization of road infrastructure. Since 2015, he's been a member of the technical product management team at the PTV Group and is responsible for further development of microscopic simulation software, which he's about to talk about now, and is actively participating in a number of ongoing EU research projects in this field. He's a certified PTV trainer and provides on-demand training specifically for PTV's Visim suite of programs. So with that introduction, Peter, the floor is yours to give your presentation. Thank you.
Thank you, Jonathan. Good afternoon, ladies and gentlemen. I will go straight to the next slide and start with a quote from Niels Bohr, who said, "Prediction is very difficult, especially if it's about the future." And that's very true also for the traffic. Traffic flow models have been developed and used to understand, describe, and predict traffic flows since the beginning of 20th century. There's a lot of empirical data available or easy to collect. Modeling standards are well established. The development is more or less stable. The technology is known. Conventional vehicle simply is not a disruption anymore. With the automated vehicles, it's a different story. There are only few automated vehicles in the traffic flow compared to conventional vehicles and with different automation levels, but fully automated vehicles are still not on the market. Automated vehicles are often a black box for the modelers. The driving logics are not public, but a secret of each car manufacturer. It is a new technology with high disruptive potential, a potential game changer. All this leads to higher uncertainty and requires a lot of assumptions. And the modeler should keep in mind that there will be a long transition phase with the coexistence of conventional and automated vehicles with different penetration rates. Next, please. The modeler needs to choose the right tool and approach for each use case based on the questions to be answered, required accuracy, and measures to be investigated. Macroscopic models are used for large-scale models, often for strategic decisions where the traffic flow is in focus. To address automated vehicles, flexible PCU factors and user-defined volume delay functions can be applied. Mesoscopic models are categorized in between micro and macroscopic models as their aggregation level is between those two types. They distinguish each individual vehicle but run with simplified models in comparison to microscopic models. For example, the accelerations are neglected or the lane change is simple and only at a mesonode. The modeler can operate with a mesoreaction time for simulation-based assignment within the PDV Vism software, dependent on own and leading vehicle type. Microscopic models are intended to reproduce individual behaviors of drivers on a road section, mainly in the so-called car following approach. They are based on the assumption that drivers adjust their behavior to that of the leading vehicle. They work with very detailed models with high temporal resolution up to 20 time steps per second. For automated vehicles, they offer driving behavior parameters and dedicated features like the possibility to switch off the stochastic if you assume a deterministic behavior of an automated vehicle. And there are also hybrid models, and they connect meso and the micro level. So you can have a large mesoscopic model and one or several microscopic areas in it. Next, please. Generally, the modeler has two options how to model connected and automated vehicles. The first one is using the internal built-in models and adapting the available driving behavior parameters to all the submodels, plus dedicated AV-related features. Next, please. One of these dedicated features might be the limitation of sensors or vehicle capabilities by setting the number of interaction objects and interaction vehicles accordingly. The idea here is automated vehicle can see the signals ahead, but only one vehicle in front of itself because the sensors cannot see through the leading vehicle. This is illustrated in the videos where two vehicles are approaching a standing vehicle, where the first approaching vehicle will turn right. The top video shows the situation where the second approaching vehicle can see the parking vehicle on time and thus comes to stop in safe distance. The bottom video shows a vehicle that cannot see the parked vehicle on time and this starts the deceleration process too late and causes an accident. Next, please. Next feature is about keeping the brick wall stop distance. The idea behind this, the vehicle can stop safely anytime without a crash, even if the leading vehicle stops instantly, turns into a brick wall. Within Vism, you can activate this option and use it for cautious vehicles. in real world, the car following parameters might depend on the leader vehicle class. That means you can have a bigger gap when an automated vehicle follows a conventional vehicle, smaller gap when an AV follows another AV, and even smaller gap between two automated and connected vehicles. All these configurations can be addressed in the simulation software. Next, please. Platooning inbuilt feature in Vissim is a special one. It is developed to simulate effects on general traffic. There is no simulation of platoon internals, which means stable driving is assumed. As a modeler, you can set few parameters like maximum number of vehicles in a platoon, the desired speed, minimum clearance, or the gap time. And you can restrict platoon creation for specific vehicle classes and specific lanes as well. Next click. And next. And next slide, please. This is a video of a platoon journey where at the beginning the platoon is formed by several vehicles, then they continue together, they increase the speed, and later on when a vehicle needs to leave the platoon, the gaps become larger, the vehicle can leave, and two separated platoons can continue the journey. Later on, if the first platoon needs to decelerate or stop because of some reason, then the second platoon can rejoin and they can build a larger platoon again. And then they continue as one platoon together. And if there is a signal or an unsignalized intersection and one vehicle cannot make it through at the beginning or at the end of the platoon, then this vehicle will leave the platoon. Analogically, if the vehicles need to perform lane change, they leave the platoon, and afterwards, when they drive on the same link, they can form a platoon again. Next, please. The second major option how to model automated vehicles is using interfaces with own algorithms. This is the choice for those who want to do more than the software itself offers through built-in features. Interfaces allow the modeler to change the behavior within the simulation to replace the car following model or to take full control over ego vehicle and let it interact with Vissim vehicles. With Driving Simulator DLL, it's possible to connect an external simulator used for vehicle dynamics and sensor simulation and create so-called co-simulation. Next click. This is often called a nano simulations if also the sensor simulation and vehicle dynamics simulation is involved. Next slide, please. And it's running. Okay, here you can see an example of a car simulation. Car maker software on the left and Vissim on the right. The ego vehicle is controlled by car maker and the surrounding traffic is controlled by Vissim. These vehicles can see each other and can interact, which means you can investigate how your control logic, your ego vehicle performs in different traffic situations and even with different types of vehicles or pedestrians. One click, please. This scheme here illustrates the process of coordinates and attribute exchange between Vissim and the external simulator. They both operate on identical network that needs to be defined on both sides. One more click, please. As you can see here in the video, there are not only the cars, there are also buses, there are pedestrians and cyclists. So it can be a very rich model. Next, please. Next slide. Yeah, thank you. A goal of the traffic modeling in the Coexist project was to assess how the impact of automated vehicles evolves during the whole period of coexistence of conventional vehicles and CAVs, from the first introduction of small number of automated vehicles until when only few conventional vehicles remain. To enable such assessment, the transition period is discretized into 3 stages. The behavior of the automated vehicles are specified by driving logics, which are functionally defined. That is, they are specified in terms of how and where they can operate safely, disregarding which technologies they make this possible. Next slide, please. Within the Coexist project, we worked with different driving logics, AV classes, stages of coexistence, road environments, and vehicle types. Since CAVs will likely behave differently in different environments, the driving logics are combined to AV classes by specifying the driving logic a vehicle of an AV class will use on each road type. So one more click, please. So that's shown here in this table. Next slide, please. Thank you. Let me show you briefly 2 use cases from the Coexist project. The first one is from Helmond in Netherlands, and it's about a transition from arterial into interurban highway. One click, please. You can see results from 3 stages defined by different AV penetration rates, capabilities, and driving behaviors. Specialty of this example was that a lot of conventional vehicles tend to overspeeding, but the AVs, they obey the speed limits strictly and have lower desired speed spread. That's why you see deterioration in travel time and some gains in delay in the prevalent stage only. Next, please. The second example I want to mention is from Milton Keynes, UK. The question was, what would be the citywide traffic consequences for Milton Keynes if CAVs become commonplace and the city center is redefined as a car-free space? Some measures were proposed and investigated as well, like creating pick-up and drop-off areas, or creating car parks, or creating car parks with additional lanes around the city center. And the results on the next slide show clearly deterioration in the introductory stage and improvement in each consecutive stage. And this is what we saw in several use cases within the Coexist project. And here you also can see the differences between the measures. Next, please. This was last slide with some lessons learned and recommendations from the Coexist project. So we implemented new features into traffic modeling tools, and they allow simulation of automated vehicles, but still there is a big responsibility of the modeler to define reasonable assumptions. Driving logics, there is much research ongoing, but there are still no fixed rule or standards, which means high uncertainties. Coexist delivered tools for a structured approach of assessing future scenarios, like automation-ready framework modeling approach and impact assessment methodology. And the use case is the simulations from use cases show the potential deterioration of urban mobility before promised benefits. So cities should plan for the transition phase accordingly. And inserting CAVs in traffic does not necessarily improve efficiency. Depends on penetration rate and driving logic. Higher penetration rates and less cautious or more advanced CAVs will start to generate gains. If you want to know more, please have a look at the Coexist webpage or contact me. Thank you very much.
Okay, thank you very much, Peter, for that very detailed analysis of how we can use modeling and microsimulation to assess the impact of AVs on the future road network. Finally, this evening, or this afternoon, or this morning, depending on which time zone you're in, we have Andrew Pearce, who is Director of Intelligent Mobility and Smart Technology at Atkins. Andrew is a technologist and chartered transport planner with 30 years experience solving safety, congestion and air quality issues in the fields of policy, design and technology solutions. He leads the European Intelligent Mobility and Smart Technology business within Atkins and is based in the UK, blending connected and autonomous transport, low and zero emission fuels, and integration of data for smart city systems and as a service mobility. He brings knowledge from periods working in the software and systems integration industry, as well as in vehicle electronics, and remains involved in research and development in such fields as video analytics and drone autonomy. So with that, Andrew, the floor is yours, and can you give your presentation, please?
Thank you. Hopefully you can hear me okay. So, yep, great. All right. So I put a picture of myself in a self-driving car there, just to be positive at the beginning, because this presentation is going to talk about some of the limitations, the challenges, the problems, if you like, of full autonomy, in order to then lead on to the good news, which is what we can do as intermediate steps, and it culminates with an 8 billion dirham potential saving before we get to autonomy from connected vehicles and existing technology. So you have to wait to the end for that bit. Next slide, please. So you've seen this diagram already. This is from the horse's mouth, as we say in the UK. This is the SAE definition by SAE, the organization. Importantly, the blue bits up to level 2 is what we have now. There are lots of cars at level 2. Levels 3, 4 and 5 are where the vehicle is doing the driving for you as opposed to helping you. So they are, you could say level 4 and 5 is no steering wheel. And this is very important if we go back to the question that you guys were all asked about, would you feel happy to make humans driving cars illegal? There's another question that often gets asked, which is, would you feel happy with no steering wheel? Most people are happy with the idea of autonomous vehicles, but not happy with the idea of autonomous vehicles that cannot be controlled by the human. So anyway, we move on from that, but the left-hand side there, we've heard different definitions today. There are all sorts of possible benefits to autonomy. If we can move on to the next slide, please. But now we get into some of the problems. So automakers in the top left corner there, the big international OEMs, the car companies, to make this work have to cooperate with a supply chain, the tier 1 and tier 2 suppliers who make the parts for the cars, who are going to be different types of company, and they have to deal with mobility companies as well. I've done work before with Honda, with General Motors, with Daimler, or Mercedes, and even just for very small pieces of work, there's a lot of negotiation. We have very different types of business model as companies. Car manufacturers are used to investing a very large amount of money before they get anything back, but then expect to make very large profit margins. So all of those grey boxes that you see, all of those grey boxes are partnerships that are having to be created and underwritten. And we're not talking about a small amount of money. This is a $2 trillion global industry. That's effectively the money spent per year buying vehicles. So people were very keen to get their terms and conditions right. And as I've said on the right-hand side, unknown asset value. They don't even know what the value of this is really, because data hasn't yet been quantified in terms of its value. So there's a couple of issues there. Can we move on to the next slide? And then in terms of infrastructure, I've highlighted in yellow on the right-hand side there, out of a lot of things going on across the world, institutional, legal things, the one that's on the right isn't mentioned too much, which is a date according to the independent organization that's named in the bottom right corner there from the US. the date when 80% of intersections would be V2I compatible, so compatible with a driverless car to communicate in two directions about the state of signals. So we would love to have this stuff sooner, but there are some things which are quite a long way away that we have to get right. And also safety parity. You know, the reason that my car can drive on a freeway in autonomous mode, but it's not allowed to drive through a city in autonomous mode, is it's more dangerous than I am at the moment. It's not good enough to handle those situations. We must get to the point where you're at least as safe or better. Next slide, please. So we've got barriers to levels 3, 4, and 5. Technology ones we know about, that's what most of the discussions are on. Institutional and governance ones, and infrastructure ones, and consumer acceptance. And that timescale of when this will all be done is going to be determined by a group of people who are not great at talking to each other, the manufacturers and the governments. And the manufacturers aren't going to make a special car for the UAE or for the UK. We're not big enough. So it has to be something that's across large areas of the globe as standards. The quote there from a BMW board director, two worlds are colliding here. Our world focused on hardware and our experience in making complex products, and the world of information technology, which is intruding more into our life. He said this in public. He used the word intruding in public, colliding. These are strong words from somebody who's trying to collaborate with a large part of the industry. So there's real discomfort about this. Next slide, please. So to put it into context, so we can get to the stuff that's the most accessible now, we have the diagram at the top. There's an area in green below of autonomous vehicles, but then there's an area to the left of it, ADAS, Advanced Driver Assistance Systems. This is a term that you should know when you talk to car manufacturers. And that goes back at least a couple of decades before any autonomy was possible, going right back to things like parking sensors, but takes us all the way through. I've got a slide coming up on the breakdown of those things. Connected vehicles, CV, sometimes talked about, started 10 years ago, or sorry, 20 years ago now in 2000. And the most common application of that is eCall, which is on a large proportion of the cars sold in the world now, a system which raises an alert by cellular phone call to an emergency centre when an airbag is deployed in an accident. And at the bottom, this fits into a framework of connected ITS, which goes back to the 1970s when traffic signals were first linked to each other, but not to cars. So what I want to talk about for the next few slides to culminate in this big saving is those two blue blocks in the middle, the ones that begin 1990 and 2000. The combination of the advanced driver assistance systems, the things that are already in the cars, and the connection, the fact that there's a wireless over-the-air connection from the vehicle to the roadside. So that information in two directions can be connected to infrastructure, which is what people that I work for are interested in. Next slide, please. So ADAS roadmap, you don't need to read all of this, but these are all sorts of systems. Every single thing on that diagram is available now on a car that you can buy and drive today. And they're filtering down. The things that were on the high-end cars very soon will be on all cars. So these sorts of technologies that monitor the world around the car, that information is in the vehicle and it can be beamed out through the wireless connection. And there's a lot of things to the right of that diagram not shown, which are commercially sensitive at the moment, but this roadmap for motor manufacturers is very well known. They know exactly what they're going to bring out in 2022, 23, 24 already. Next slide, please. So if we put together ADAS, those advanced systems which are gathering lots of really great data, they're gathering data about the suspension movement, the steering, the temperature, the air quality. They're gathering all of this and sending it around the vehicle for the purposes of the vehicle. If we can get that via an over-the-air connection, and all of these cars have a built-in SIM card, then we can get lots of benefits. And we've done this for the UK, and we can transfer this to anywhere in the world. We grouped the benefits under those 7 groups. mainly because of the technology that goes behind each one of them. Next slide, please. I'll give you a couple of examples just to make this real. So very briefly, one example on asset management, which would be of interest to any highway authority, any road operator or municipality. This project done with Daimler, who are credited in the bottom corner there, looked at monitoring the condition of the road surface. So for lots of governments, the road network is its most valued asset. In the UK, it is the single most valuable thing that our government own, and it needs to be looked after. For that reason, of course, for reasons of safety. So we currently do this. We assess the condition of the road network using surveys, which are expensive. They can only be done every so often, and damage occurs in between surveys and gets worse and becomes expensive to fix. That causes accidents. Every vehicle driving down the road is detecting what's going on in the road surface, and the more expensive vehicles are collecting this information internally and can send it back over the air. So we did an experiment, next slide please, to take various different feeds from inside the vehicle and combine them together. This is called multivariate analysis, or fast Fourier transform, which is looking at any patterns. Take 10, 20, 30, 100 different data sets, correlate them over time and see if more than one thing pops out as an exception or a rhythm or a pattern, and see if you can use that to detect something that you're looking for. In this case, we're looking for damage in the road surface. We got enough data sets and an algorithm smoothed to show on the next screen that on the next slide, please. On the left-hand side, those are readings going up and down one road. And on the right-hand side, after smoothing them through an algorithm, we have, you can see 4 areas of orange. Now, 3 of those areas of orange are where there are known intersections. So we expected to see movement of the vehicle, not just in a straightforward direction. And the 4th one, there is no intersection, and it is where there's damage on the road, which we knew about. We did this on lots and lots of different locations to refine the algorithm. So in a nutshell, what you have there is a project which says it is possible with existing data coming out of existing vehicles, crowdsourced, free of charge, depending on what commercial arrangements you make for the data, to know where there are defects on your road network. The same algorithm can also detect accidents. It can also detect broken down vehicles. It can also detect congestion. So next slide, please. Another example is cooperative traffic signals. So again, we're not talking about, sorry, my monitor's just gone off. Okay. Again, we're not talking about driverless cars here. As a reminder, this is just connected vehicles. This is projects that can work in the next 1 to 3 years. So this example of cooperative traffic signals, or GLOSA, green light, advisory, speed adaptation, green light optimization, speed advisory, sorry, GLOSA, or SPATS, sometimes known as in the US, signal phase and timing. The display that you can see on the dashboard there, the second display, is telling the driver what speed to drive at in order to arrive at the traffic lights when they are on green. This is obviously great for safety, and it's good for capacity as well. Next slide, please. But coming back to our question about how does RTA save money, how does a highway authority save money? This is the implication for an authority like RTA. Number 1, if vehicles know their own position and they report it over the air, which they can now, then detection can be removed from traffic signals. Number 2, I2V, infrastructure to vehicle. It is possible then to use that same link for the traffic signals to send a message to the vehicle, as you saw in the previous slide in that photograph, telling the driver what speed to travel at. This is not an autonomous vehicle, this is a human, but a human being advised in such a way that the capacity of the signals rises. And then the third option is that the communication goes in the other direction, that the car tells the traffic signals to change. Next slide, please. So don't read all the detail on these next couple of slides, but just in terms of process, we took those 7 different technology areas and then arrived at a set of actions that needed to be done to yield benefits to move this forward. With the examples we just showed, there are obvious questions there about a tie-up between the people who have the data and the people who need the data. Next slide, please. The actions then appear around the outside of here in the dark blue writing. Next slide, please. And of course, these things can be ranked in terms of their difficulty and their cost and who needs to take action. So this is all about being really pragmatic and getting stuff done, getting it moving. We won't do all of these things in the UK. We won't do all of these things anywhere, but we will be able to do some of them and get some of the benefits straight away. Next slide, please. And then for each one of those things, a more detailed action plan is produced with what's required now, next, and in the future. Okay, so here we're getting to the financial stuff now. The data types in the middle column say for each of those 7 categories what type of data is required. So that top one, asset management, relates back to the road damage, the road condition monitoring project, in that clearly it's accelerometer and photographic data that's crowdsourced for defect reports. And in the right-hand columns there, we see the cost saving for road authorities as being high for that one, and the economic saving. This is different. This is not a cashable benefit to a road authority. This is the economic benefit to wider society as being not so high. But importantly, the final column, the timescales on these, there's one that's 5 to 10 years, one that's 3 to 5 years. Everything else is either now or within 2 years. Next slide, please. So as promised, the breakdown of this, and this does come from a very, very, very large set of data and research, and we summarized it as much as possible to be useful. In the first column, the total, 433 million, and this is pounds, UK pounds. So very similar to dollars at the moment, really, for the purposes of this, given the accuracy of this information, you can consider them almost the same, multiply by 4 or 5 to get dirhams. So this is something of the order of 1.5 billion dirhams of cash savings per year, every year for the future, compared to the way that we do things at the moment, if we were able to use all of these facilities of connecting to non-driverless, connecting to regular normal cars, extracting data, and using this instead of having expensive infrastructure instead. The next column on economy is savings of double that amount in addition, and these come from other benefits to, let's say, government. So if government has targets for congestion or air quality, then they would appear in this second column. They're not necessarily something that you would receive in cash as a government, but you may well be able to offset other expenditure that's needed to achieve your key performance indicators instead. And the third column with the really big number, GDP, be careful of this. This is to do with people's time, and this is why it's such a large number, because a number of these initiatives would make traffic control better, would reduce delays, and as a result of that would release people's time. So we think that the most relevant number for a road authority is the first 2 columns together, the cash plus the economy, and that comes to 1.5 billion pounds, $2 billion US dollars, or 8 billion dirhams per year, every year from now on. To put 8 billion dirhams into context, well, in the UK, we have in billions of pounds, that chart on the right-hand side, how much we spend on health, education, defence, etc. So our defence spending in the UK per year is 41 billion pounds. And getting on for 2 billion pounds worth of savings could come just from these projects alone. And this is before autonomy. So it's a really, really significant contributor to the economy. And final slide, please. I'll remind you my email address and phone number at the bottom of all of these slides if you want to get in touch. The important thing here as well to remember is that the priorities, actions and so forth for this are different from, if it's not in the UK, the process that we followed is the same. But obviously, if the valuation of who saves money comes down very much to who currently controls and runs the taxi concessions, tolling, enforcement, parking costs and so forth. Also traffic densities and safety record I think would enable actually bigger savings in many places than in the UK, because we don't have a particularly bad safety record and we're trying very hard to reduce that. The marginal reductions are becoming quite difficult. And finally, use of existing systems and integration. So, you know, a lot of this would require cooperation with Etisalat and Do. You're very lucky to have two operators in the country, in UAE, and integration with Salik in the UAE, in Saudi, with the Sahar system, with the logo there. I think we're a bit ambitious asking to integrate with Falcon in Abu Dhabi, but who knows, we've got to aim high. But certainly those sort of integrations affect all of the mathematics and also the feasibility of this. And that is the end of the presentation. Thank you.
Okay, thanks.